So in this problem, Caroline, we're given the function g of x, and g of x belongs to the family of exponential functions that I have labeled over here in my upper right-hand corner, f of x. The number in front, obviously, of the base of our power is always the y-intercept. So this particular function would pass through the y-axis at 1/3. And then the base here is e, which we of course know is equal to the number about equal to 2.71828. And we're asked to graph the function g on this coordinate plane. So the first thing we want to recognize is that g of x is, or f of x, let me refer to the parent function. F of x is a exponential growth function. And the reason it is growth is because the base of our power, in this case e, is a number greater than 1. E is greater than 1. E is about equal to the number 2.71828. And that's why this is exponential growth. So if I just did a quick sketch of what this function might look like, it's going to cross through the y-axis at 1/3, and then it's going to grow exponentially. And as all exponential growth curves have, it's going to have an asymptote on the x-axis at y equals 0. So what we need to determine then are a few of the points that lie on that parent function. So I'll make myself a little table of values for points on the f of x function. We already know it goes through 0, 1/3. Another point that we know it goes through is if I put a 1 in for x, e to the 1 is about 2.71828. When I multiply that by 3, or rather 1/3, I get about equal to 0.906. Okay, this is a little trickier. Given the tools that we have on Alex, I'm thinking that we might want to enter this as e over 1/3 in parentheses. Now e divided by 1/3 is the same as e times the reciprocal of 1/3, so that would be 3e. So we could also enter that point as 3e. I don't know if Alex will allow us to do that or not, but I wanted to give you another option. So then we have to consider the fact that there's some transformation going on here. We see in the equation that we're subtracting 3 from the x in the exponent. So that means we're going to move to the right 3 places. And we also see in the equation that we're subtracting 4 at the end. And that means that we're going to go down 4 places. So if we were to, I'm going to go to just a blank screen where I have a little bit more room. If we were to take the points that we have has to, oops, I accidentally went back to the last page, has to go to the right 3 and down in our table for the parent function, f of x. We had 0, 1/3, and we had 1, 3e. And again, I'm just not quite sure how Alex requires you to plot these points given a base of e. I'm guessing they're going to give you an e on the calculator. But our g of x function, 4. So to the right 3 of 0 would be at 3, and 4 down from 1/3 would be 1/3 minus 4, which if we use the help of our fraction key on our calculator, that'd be 1/3 minus 12/3, which is equal to negative 11/3. The point at 1, 3e, I have to go to the right 3 of 1, which would take me to 4, and I would have to take 1/3, excuse me, not 1/3, 3e, and subtract 4. And I'm hoping that Alex will allow you to do that. Otherwise, maybe a decimal approximate will be appropriate. Again, I'm not sure what that looks like on their end. Now, every exponential growth function we know has an asymptote at y equals 0. Because this function is going down to, g of x is going down to, then instead of having an asymptote at y equals 0, we're going to have an asymptote at, sorry, not down to, down 4. We're going to have an asymptote at y equals negative 4. And when we plot these points, 3, negative 11/3, that's negative 3 2/3, so almost negative 4, just to get an idea. And 4, and then if I approximate the value of 3e minus 4, that's about equal to 4.15. So when x is 4, we go up about 4.15. We might have to look at this one together tomorrow just because I have to see what they do on the Alex side of things. And now the asymptote, of course, is going to be at y equals negative 4. So if I connect those points that I have drawn in, sorry, that's not a very good picture, but you get a general idea. The curve would look something like that. And again, we might just need to look at this problem together tomorrow, Caroline, because again, I'm just not sure how it's going to allow you to plot these points with a base of e. Let me know if you have other questions.